Okay, so today our lesson is SI units, and these are the learning outcomes of this lesson. So after this video is over, you can understand each and every point mentioned here. So let's get started. So what are the SI based quantities and their units? Basically, mass, length, time, current, and temperature are called SI based quantities, and their units are always kg, meter, second, ampere, and Kelvin. Remember that mass has a lot of units, right? We can measure it in gram or, for example, in pound. But the SI base unit of mass is kg. Same goes for length, it is meter. For time, it is second. For current, it's ampere. And for temperature, it's Kelvin. So let's see what kind of question we will find regarding this topic. So we will find questions like find the SI base unit of force or work done or pressure or voltage. Let's solve each one of them and we will try to understand while solving them. So if I am asked to find the SI base unit of force, let's see. How can I represent force? I can write force equals to mass into acceleration, right? So the unit of force is Newton and the unit of mass is kg. We know that we have to write here in the SI base unit, and kg is a SI base unit. So we are here writing kg, and for acceleration we write meter second inverse square. So you see here we have meter, which is also a SI base unit as mentioned here, and we have second here, which is also a SI base unit. So basically, if we are asked to find the SI base unit of force, it is kg meter S inverse 2. As simple as that. Let's see another example. How about work done? So we know that work done equals to, for example, force into distance, right? So the unit of force is Newton and the unit of distance is meter. Now we know that meter is a SI base unit, but Newton is not, right? So what can we do in this case? In this case, we have to convert this Newton into SI base unit, and based on this, we know that the SI base unit of Newton is kg meter per second square. So let's write that. It's kg meter inverse 2 meter. Let me repeat how I found this one. We know that the unit of force is Newton, but we need the SI base unit, right? For finding the SI base unit of work done. So we know that the SI base unit of force is this one. So we will just find this one if this one's not asked to calculate first, and then we find this, and if we simplify it, we can write first kg and then it is meter into meter, which makes it a meter square, and S inverse 2. As simple as that. Let's see another example of pressure. Let me remove this force as we have completed the force one. Okay, so for pressure, we can say that what is pressure? Pressure is force per unit area, right? So what is the SI base unit of force? We know that it is kg meter per second inverse square. So I can write kg meter per second square, and area is meter square, right? So we know that meter is a SI base unit, so I won't change that. And we know that the SI base unit of force is kg ms inverse 2 based on our previous calculation. So I can say that the SI base unit of pressure is this. So now you might ask me that, can I keep it in this form? Well, you can, but I think you should simplify it. How we can simplify it? So there is meter square divided, which means it's meter inverse 2. So it's basically, if I remove this from here, I can write it as this, right? Same thing. So if I simplify it, it stands for kg meter minus 1 S inverse 2. As simple as that. Let's see our last example, voltage. Let me just clear this up. Alright, so we know that voltage is work done per unit charge, right? So here we know that the SI base unit of work done is kg meter square S inverse 2. So just let's copy this part. It will help us here. So for work done, this is the SI base unit, and for charge, we know that charge is current into time, right? Q equals to IT. We learned it, right? In O level, Q equals to IT. So the unit of current is ampere, which is a SI base unit, and the unit of time is second, which is also a SI base unit. So the SI base unit of voltage is kg, this one, simply this one. Now if I ask to simplify it, you can convert it to, suppose, like this, like kg meter square, and then there is minus 2 and s inverse 1, so it's minus 3, and then there is ampere. So this here is the SI base unit of voltage, as simple as that. Now let's talk about something very important. So throughout your A level, you have to understand that in every calculation you will always use kg during mass. For length it will be meter, for seconds, for time it will be seconds, for current it will be ampere, for temperature it will be Kelvin. It means that you cannot use centimeter, you cannot use gram, you cannot use minutes, or you cannot use any other unit. Why am I telling it? Well, during the calculations you have to use them to get the correct value, even if your question asks for a different unit. For example, I ask you to find the value that I give you a question which asks you to find your final answer in millimeter, for example, but you have to do all your questions, all your calculations using these units, and then you have to convert it to millimeter. Now for example, you have a question which has 5 different values, and you need to do calculation using 5 values, and the 5 values are not in these units. For example, you have a kg which is in gram, you have a meter which is in centimeter. In such cases you have to convert each and every one of them to SI base unit, then do the calculation, and then give the final answer in the unit asked in the question. Now you might say that it will be very hard to convert each and every unit, right? And you might be like, why am I going through this trouble? But to maintain the units, to get your correct answer, you have to do it. And to convert the values, for example, you have a lot of variables and a lot of values, and you need to calculate them easily. You can always use prefixes. Where did the what are the prefixes? For example, you have a value in deci, for example decimeter, or for example or example decigram, or you have a value in millimeter or milligram, and you want to convert the value to a standard value. For example, for deci you want to convert it to, for example, millimeter, you want to convert it to meter, right? So to convert it to meter, what you need to do is that you need to for example, I have 2 millimeter and I want this value in meter. Why meter? Because we know that all our calculations need to be done in meter. So to find 2 millimeter in meter, I'll just multiply 2 into 10 to the power minus 3 and I'll get my value in meter. For example, you are given nano, for the like nanometer, and you want to convert it to meter. You will multiply, for example, I'm given 2 nanometer and I need to convert it to meter. So I'll write 2 into 10 to the power minus 9 and it will be meter. Now it's about these as well. For example, you are given mega. For example, you are given mega like megameter and gigameter or something in giga or mega. How to convert them to a normal value? By multiplying this value. For example, I'm giving you a gigameter. So to convert it to meter, you will multiply. For example, I have 10 gigameter, and to convert it you will multiply 10 into 10 to the power 9 and you will get meter. So the prefixes will help you calculate a lot faster and it will just speed up and it will eliminate any kind of confusion you have during your calculations and speed up the process. Okay, so next we have homogeneity of a physical equation. What does it mean? It means that all the terms of a physical equation must have the same unit. Well, first you need to understand what do I mean by terms of a physical equation. For example, we know that V equals to U plus AT, right? It's a pretty simple formula where V is the final velocity, U is the initial velocity, A is the constant acceleration, and T is the time, right? So by term, I mean this. This is, for example, one term. This is another term of this equation, and like this, each and every equation has a term. This is another term. But how about F equals to ma? This equation has one term and then another term, and this means, and according to the definition, it means that this will have a equal unit like this and this will have an equal unit like this. Let's see if this actually works. So we know that the unit of velocity is meter per second inverse 1, right? Okay, so u is also meter per second inverse 1, plus we know that the unit of acceleration is meter per second inverse 2 and of time it is second. So if I simplify this, I can simply write it as meter per second inverse 1, right? So meter per second inverse 1 plus equals to. So basically this proves that this part is equal to this per unit equals to this unit. All terms of a physical equation must have the same unit. This is velocity, this is also velocity, this is the final velocity, this is the initial velocity, but it is a velocity, right? And acceleration into time is also a velocity. We can find it by solving the units. Okay, let's see another example. Let me just remove these things from the video and I think you can look better if I remove them. Alright, so we know that S equals to ut plus half 80 square, right? So in case you guys don't know these equations, these are equations you will be using in the future, but for now just remember this, that these are equations to find, for example this one is to find the distance traveled if an object is moving with a constant acceleration in a straight line. Okay, so basically to solve this, let's see if this proves the homogeneity of equation. This is s, which means it's distance, so it's meter. It's u into t, which means speed into time, so it's meter per second. Inverse 1 into second, so this cut, so it's meter, plus it's meter per second inverse 2 into time square, so it's s square, right? So this is also cut. So basically this is meter equals to meter plus meter. This means that each and every equation you are studying always follow this rule. That means that all the terms in equation will always have the same unit. So that's it about homogeneity of equations. So let's see what we have learned in this topic. We know that the SI base quantities and their units, these are the SI base quantities and units. We know how to derive units as product or questions, and the SI base units and the use the name units listed in the syllabus as appropriate, blah blah. We have found the SI base units here, and then we have use SI based units to check the homogeneity of physical equations, which we did here. And last but not least, we have used the following prefixes that we learned here, that we need to memorize these prefixes, which will help us to ease our calculation or make calculations faster and not get confused. So that's it about this topic. I hope you understood everything, and I understand that it might be a little bit hard for you to understand through the videos. So if you have a problem, you can always leave us a comment and I'll try my best to help you out there. Thank you very much.